Okay, so occasionally we'll be asked a question about what could cause something to take place. And in this particular circuit, this is a working circuit right here. It's 24 volts DC. And we can solve this using Ohm's law. Of course, VT is easy. It's 24 volts. And RT is just a matter of adding up all the resistors. So let's do that real quick. And then we can calculate our current. So 37 plus 33 is 70. So plus 47 is 117 ohms. So I have to kind of write that up here. I'm about out of room. Do it like that. 117 ohms of resistance. So again, V over I times R. Whoops, that didn't work out too well. So let's fix that. Right. Doing it with this mouse is a little more difficult. So we've got our V and R, so we're covering up I, so we just simply divide 24 by 117. I'm going to do that over here on the calculator, and we'll write it up here in just a moment. I should have came up over here, so that's fine. 24 divided by 117 equals 0.205 or 205 milliamps. So IT, I guess I'll write it right here. If I can squeeze it in, equals 0.2. That was like a delta, but it's not. It's a 0.205 amps. Now we can validate that. We'll stop this simulator for a minute. We'll pop a current meter in there, ammeter. And again, it doesn't matter where we do that at because current is the same at any point. So draw, and we're going to do an ammeter. And here we go. I didn't connect it. There we go. Up, I drew two of them in there. Again, I forget if you ever let go, it's just going to draw another one. All right, we got it connected. So 205 milliamps or 0.205 amps, which is what we calculated. So our circuit solving was sound. Like this circuit suddenly begins drawing X number of amps, and it's supposed to draw this amount of amps, the 205 milliamps or 0.205 amps, and it'll say things like, could this value have changed to this value or whatever? And the way to do that would just simply be to solve that circuit with the new parameters. So for instance, we know that as resistance lowers, then current rises. So if this 47 ohm suddenly became 4.7, we're going to see a rise in current. So I'm going to right click on him, and if we inadvertently put a 4 instead of a 47 ohm, watch what happens to our current. See, our current went up significantly, almost by half, or a little more than half. So putting in a wrong component can cause this kind of stuff, and that's what we need to be questioning and asking ourselves when we're troubleshooting a circuit. We know how it should work. We know the values that should be there, but we're not getting them. I'm going to fix this back to a 47 ohm. It's not often we have a wrong supply voltage, but I wanted you to see what would happen if we did. So now we're back to our 0.205. But what happened if that supply, instead of 24 volts, was 48 volts? Well, our current doubles, and that's because our resistance has remained the same and voltage has doubled. So we've hooked to the wrong supply, and we're getting wrong values as a result of that. So if we fix that supply voltage, we would be okay. Now we may have harmed our circuit if it's set to only work on a particular voltage value, voltage level. So we saw that if we drop that down to a 4.7 current increased, what happens if we put 100 ohm up here? Well, current's going to decrease significantly. So let's see that happen. And you see we dropped again by almost half, not quite half in this case. But we can put a wrong value resistor in here and change the whole working aspect of the circuit just by doing that. So this is where our knowledge of Ohm's law and troubleshooting. So if I were to ask a question, like this circuit's supposed to measure 0.205, suddenly it's measuring about 120 milliamps or 0.12 amps. What could cause that? And I say, could it be, R2 triples in value, or R1 was supposed to be a 10 ohm and became 100 ohm? It's just a matter of plugging in those values, solving the circuit with those values, and seeing which one fits that bill. But we can also put it on here and see what happens. So again, fall stack can be your friend in helping you see visually these things, and it can help you understand how troubleshooting comes into play when we have issues that do arise, such as what we have here. And it's a good tool to play with to help understand the relationship of current, voltage, and resistance in Ohm's law in series and again in parallel. And parallel changes the rules a little bit, but when you think about it, it makes sense. And this is a good tool for visualizing and seeing that right before your very eyes. And of course, as always, questions, see us.